Okay, so this is a typical failure of a dual head. This heater block working fine, this heater block fine-ish, except it's pouring plastic out the top. Now, I'm pretty sure this will be down to the top insert. The thread's so fine that it's 0.5mm thread pitch, and I've had a chat with Cell and they said that even at factory sometimes they get over tightened during the build, and they strip the thread so they're very loose, and as soon as you get any back pressure or pressure build up in here through extrusion, it lifts the top insert out and it oozes between the top insert and the block. So it's not the O-ring seal that sits around the needle valve, it's the actual metal bush that gets pushed in there, the threaded piece. It just doesn't bite into the thread in the aluminium block and then causes this to happen. So I'm going to take this off and we'll see if that is the case. And the only thing I can think to do is thread lock it and see if it keeps it held in place. So I've taken out the first screws out of the case, which are located in those positions. So to get this heater block off, I'm hoping I've got an idea that I don't have to take all this lot out, because it's quite easy to get things damaged up here at the top, break little tiny micro switches off that pick up the nozzle switch, or just generally screw it up. So I'm going to try a little theory. I think if I unscrew, well, first of all you've got to pull off this clip. I'll just do that. Our cat's having a whinge in the background. Grab that and put this out of the way, slide that off out of the way. Right, so I'm reckoning if I unscrew this and unscrew that, I think the only thing that's holding that heater block in place is the titanium heat bridge, which you'll see in a sec, and basically the friction due to the nozzle being cold and the plastic sort of stuck against the needle valve. So pop these out. Hello. Pop that out of that. Pop that out of that. So while it's apart, another top tip for these is PTFE tube that comes from these as standard. Sometimes a little bit short on that. Interesting, it's not too bad on that one. But what can happen sometimes, especially if you use, say, PLA as one material and say ABS or PTG another, it can stop feeding into the head, basically because you get quite a bit of heat build up through the difference in materials down here, and the PLA, because it can go soft at sort of 50 degrees, if this tube is not absolutely square up to here, well, it's interesting to see that it's not, you can see it on here, you can see it's very square. If that PTFE tube is slightly short of here, what can end up happening is if it gets hot, the PLA as it's coming through can soften a bit and bulge, and you end up with a squared off edge of PLA in here, which stops the PLA going forwards into the head, and it also stops the PLA being able to pull out, so you get a completely jammed head. And the only way to fix it is to do what I'm doing. I'll take it completely apart and then pull the PLA out and then have to reassemble the head. It's not ideal. So if you do take one of these apart, it's worth making sure that this tubing that they've got goes right up to the very edge and there's no gap at all between it and the back of the head. I mean, I actually went a little bit more extreme than that. I ground this completely off, so it's the same diameter as the PTFE tube on both sides, and just put a longer piece of tube in that went all the way to the edge of the head. That's the way of doing it. The only thing is the tube, if you put a little bit of paper or something in here just to clamp it tight, the tube sometimes on the odd occasion can come out, but in general use it won't come out because it's secured in the head. You know, the X carriage is there, the tube can't move either way, but you might on the odd occasion find you pull it out. Anyway, back to this, taking that all out. So I think, so the only thing that's holding this in place now is this titanium bit, which if you heat it up you can sort of bend out of the way, and then I think the friction on the nozzle. So I'm going to try that and see what happens. So that's pretty hot now, so I reckon that will just bend out of the way. Okay, so it turned out it was easier in the end. Best thing to do was to, this was all in there, was to unscrew the metal T-piece between the heater blocks, this metal piece here, unscrew that, and then just lift the whole thing off. I've not touched any of the grub screws on here because these are sort of set for the nozzle opening. We'll talk about that in a minute, or later on in the video. And then literally just a case of heat up the heater block, and wait till the plastic sort of, so it's just a case of heat the heater block up, wait till the plastic's bubbling away a little bit, and then just pull the needle nozzle straight out. So sort of clean it up a bit. Now I've cleaned some of the plastic away. Now, not, oh god, that's still pretty hot, that. Not 100% convinced yet, but I suspect what the problem will be. See this insert at the top that screws into the heater block, a bit like these screw in the side and the nozzle screws in the bottom. It is not, use this needle, it is not the O-ring seal to the needle valve, which is inside. It's actually, I'll have to point to, but I bet if I heat this top block up now and wobble this thing, this insert will be loose. Even though it looks like it's screwed into the block, it's not. And it'll be the screw threads that have been over tightened at factory or poorly machined, and it's just going to wobble about. So what happens is the plastic comes in, it gets hot in here, there's a little bit of resistance even when the nozzle's open as the plastic's being forced in to squirt it out. Some comes out the bottom, some lifts this up by hardly anything, and then it all oozes out from underneath the flat of this piece, and that's where your problem is. So I'm hoping it's that, because the O-ring side's a lot harder to sort out, and it means you have to take the whole thing apart. So I'm going to heat this up again and see if that lifts up or wibbles about, and if it does, that's the problem. Well, it's quite an interesting one here. So that's the block. I've unheated it up and then to the point where I could unscrew this insert. So you can see it's quite a fine thread on there. I can get this to focus on there. I'm not getting the focus come. There we go. And that thread doesn't look too bad in there actually. Looks reasonably well formed. but the problem was, look at this O-ring. If I can get this to fit, that'd be amazing. There we go. I'm not sure if you're going to be able to see this clearly, but this O-ring is mechanically damaged at factory. It's been inserted, and it's very difficult to show this. I'll show it in my hand better. You can see it's damaged there. It's mechanically it's been chafed and ripped. So that's not great, really. So that's why that hasn't lasted very long, and that's only had PLA running through it. So I need a new O-ring. And what I am going to do while this is apart is, when I put the O-ring in and put this back in, I'm going to thread lock this in there. It's a bit permanent, but the other failure mode of these things is, like I say, the threads aren't put brilliantly, and it leaks round the threads and comes out from underneath the flat rather than leaking out of this hole where the needle valve is. It turns out on this particular case it's leaked out from the hole rather than under the flat because the O-ring was buggered. So I'm going to see if I can find an O-ring off a junk head somewhere and drop it in. Okay, so there's 2 O-rings from a previously failed head, and this one here is the one that's ripped. So yeah, there we go. Not good. But hopefully got one of these in. Okay, so what have we got in there? So the O-ring has gone in. And needle valves here. So the interesting is the O-ring, very easy to buckle the O-ring and have it folded on itself and it not be sitting in there neatly. It's very difficult to get the whole chamber clean as well. But if I push that needle valve in there now, that's nice and tight and sealed against there, so that's pretty good. Who knows whether that's clean enough in there or not. It certainly doesn't look it to me. But I'm not sure what else I can do. Let me just take out some of these. So there's something. It doesn't look great, that O-ring. I might just pop it out actually. Let's have a look at it again, if I can get it out. It doesn't look very good. I'll have a look. It doesn't look great. So I might think the other O-ring, actually maybe the other O-ring's a better one to use. Yeah, I think I'll use that one. So yeah, that one's better. It turned out the other one wasn't obvious, but it was split. So we'll stick that one in, and I'm going to thread lock the thing back in and see where we go.